Now we have a concept of visible surface determination or hidden surface elimination. There are two types of methods in this: object space method and image space method. In object space method, we work on the objects. So we compare the objects and then we see which objects will be visible from a particular perspective. Whereas in image space method, we look at every pixel position and we try to judge which pixel position is at a particular pixel position, which color is visible, or which color should that pixel have. So when we go by pixels, it is image space method. When we go by objects, it is object space method. This is very crude kind of explanation, a very simple kind of explanation for object space method and image space method. Going ahead, we have a concept of coherence, and then finally we come to the topic of very importance for us, that is the algorithm. So there are total 7 algorithms you have to see. The very first one is backface removal. Backface removal algorithm works on the equation of polygon surface, that is ax plus by plus cz plus d is less than 0. Now every surface has a normal vector which is represented as n, and it has 3 components, a, b and c. Obviously, A component belongs to x-axis, B component belongs to y-axis, and C component belongs to z-axis. Now, what we do is, we say that a polygon surface is a backface if the dot product between the viewing vector and the vector normal is greater than 0. So, vview dot n, if it is greater than 0, then it is a backface. Now, let us consider that vview dot n is equal to vz dot c. We are able to say this if the viewing direction is parallel to the z-axis. So when vz is positive, we check the sign of c component. C is called as the z component of the normal vector. If c is less than 0, this is as per the right-handed viewing system. If we consider the left-handed viewing system, these equations will be exactly opposite of what they are right now, because in left-handed system the positive z axis points towards the viewer. Okay, now if c is less than 0, then it is a backface, it is not visible to the user. If c is equal to 0, it is gazing the polygon, not visible from the viewing position, and c is greater than 0, then it is visible to the user. Now, as you can see over here, which faces are visible to the user and which faces are not visible to the user. So, in short, this was all about backface removal algorithm. Now, we move ahead to the next algorithm, which is called as z-buffer or depth buffer algorithm. In this algorithm, we mainly have 2 buffers, the frame buffer and the Z buffer. Frame buffer will store the intensity values for which surface is visible at every pixel. Z buffer will store the Z values or the depth values of the pixel, which is, of the closest surface for every pixel. So how does the algorithm go? सबसे पहले we initialize the values of Z buffer and the frame buffer. The initialization happens as follows. Z buffer we initialize with the minimum depth value or a very large negative value, and the frame buffer we initialize it to the intensity of our background. So in this case it will be light blue color. Now for every position on each polygon, we compare the depth values to the previously stored values in the depth buffer. So for example, earlier in depth buffer the value stored is 0, and right now you can see we have dark blue color polygon which is above it. So just uska depth value Z buffer value क्या होगा उसका 1. So Z buffer में already क्या है 0. If I consider blue color polygon, what will be its Z value? It will be 1. So 1 is greater than what is there in your Z buffer. So you update the value of your Z buffer to 1, and frame buffer will become I surface x comma y. So at this pixel, what is the intensity? It is dark blue. So from light blue it will become dark blue. If this is not the case, if the new z value is not equal to the z buffer or it is not greater than the z buffer, then you don't do anything, you just proceed. So this is the base concept for z buffer algorithm, also called as depth buffer algorithm. Now advantages and disadvantages, I leave it up to you to just read and go through it once. उसके बाद Painter's algorithm. Painter's algorithm is, the process is very simple. You first sort all the polygons. So you need to know the z values or the depth values of all the polygons, and according to the depth values or the z values, you sort them from furthest to the closest. Okay. Then you draw. Render is nothing but you draw each polygon in a sorted order. You begin with the furthest polygon and then you come to the nearer ones. Whatever you have drawn earlier, those pixels are obviously going to be overridden if the polygons overlap. Okay. Now, in case there is a cyclic overlapping, then it creates a problem, because then there is no straightforward way to sort the objects from back to front. So you need to look at from different angles how the objects are going to overlap, especially if there is a case of cyclic overlapping. Again, advantages, disadvantages, I leave it up to you to read and do. I have given you the example of cyclic overlapping and penetration. These are the problematic cases in Painter's algorithm. उसके बाद आता है scanline method. In scanline method, we always maintain a list which is called as active edge list. So active edge list will contain only the edges that crosses the current scanline. So scanline goes from left hand side to right hand side one by one from top to bottom. So what we basically do is, whenever the scanline reaches the leftmost boundary of the surface flag is turned on, and when it reaches the rightmost boundary, it is turned off. So active edge list is maintained containing the edges that intersect the current scanline. So when it enters the projection of a polygon, the on flag goes on and the beam switches from the background color to the color of the polygon. And when the beam leaves the edge of the polygon, the flag again goes off and it switches back to the background color once again. Now, when the scanline finds that it is intersecting two or more polygons, then only you perform the depth sort and you select the color of the nearest polygon. So, see the case of scanline 2 over here. As soon as it intersects the edge AD, the color switches to grey. As soon as it intersects the edge EH, it understands that already the flag was on for the earlier polygon, now it is on for the next edge, that is EH. So it will do the depth sorting and it will see which polygon is on top. So if the grey color polygon is on the top, it will continue painting the grey color. But when it reaches B to C, BC edge, the flag goes off for the first polygon, so the color changes to the color of the second polygon, which is white in our case. This is how it works. Area subdivision method is another method where, what you do is, we divide our entire viewing area into small rectangles and we continue this process. And we get one of the 4 cases. The one of the 4 cases are listed over here. You either get a surrounding surface where the polygon is bigger than your area. Overlapping, half of the polygon is inside the area, half of the polygon is outside. Inside surface, the polygon completely lies inside your rectangular area, which you get by dividing the image. Outside surface, the polygon is completely outside. Now what do we do of all these 4 cases? We try to make the decision about division of an area, whether you have to go ahead and divide further or how you have to go about it, by looking at one of the 4 cases. If all the polygons are disjoint, that is, they are outside the area, you just display the background color because polygons are outside, you don't have to worry. Only one intersecting part or it is interior, then you fill the area with the background color and then scan convert the polygon. So only those pixels you will color with the polygon color. A single surrounding polygon and no intersecting or contained polygon. Obviously when it is the case of surrounding polygon, what you do is you just color that area with the color of the polygon. More than one polygon is intersecting, contained in or surrounding the area, but the surrounding polygon is in front of all the polygons, then the area is filled with the color of surrounding polygons. We are comparing the z coordinates. So even if certain polygons are partially inside or completely inside, but the third polygon which is there, it is on top of all these cases, all these polygons, then obviously you know जो नीचे वाले पॉलीगॉन्स है वो वैसे भी विजिबल नहीं रहेंगे. आपका काम बहुत सॉर्टेड है. अभी इन चारों में से एक भी केस नहीं हो रहा है. व्हाट यू हैव टू डू, you have to divide that rectangular area into 4 equal parts and recursively apply this logic till either one of the 4 criteria is not met or you are coming to the pixel size, pixel level size pixel, जहाँ पे और breaking polygon और breaking area का possible नहीं है because now you have reached a pixel level size. So वो pixel का color determine कर लो and वो color का pixel उस color से pixel color कर लो. So जब तक pixel level size नहीं मिलता है या one of the 4 criteria meet नहीं होता है, go on recursively dividing it. Okay, one example is shown over here how you can do it. Now we go to the next one, that is binary space partition trees. In binary space partition trees, what we basically do is we try to calculate the visibility by making a tree structure. So how is it done? Let us consider a very simple example over here where we are having A, B, C, D, E. Okay, so how did I get these trees? So let us say that A is over here. So A के front side में क्या है? C and B. So whatever is in the front side goes to the left hand side. And whatever is in the back side goes to the right hand side. So front का जो है वो left पे गया. Back का जो है वो right में गया. Remember Baskin Robbins. जो भी back में है वो right side गया. अभी B से पूछ लो. B के front side क्या है? A. But A is already covered so we don't have to worry about A. What is there on the back side of B? There is C. So now C goes to the right hand side of B. Similarly, ask D. What is in the back side of D? Nothing. So you can see the right side of D is empty. What is on the front side of D? E. So front side में था, इसलिए E goes to the left hand side. This is how it is drawn. It is one more example. Over here, if you carefully observe what is happening is, we are starting with the root node that is 3. Now observe very carefully. Front side में क्या है? 2 and 1. So 2 and 1 go to the front, left hand side. Back में क्या है? 4. But what about 5? You have to divide 5 into 2. Front में 5A है, so 5A goes here. Back में 5B है, so 5B goes here. Okay, now you consider 2. 2 के front side क्या है? 5A. So 5A goes to the left hand side. 2 के back side क्या है? 1. So 1 goes to back. अभी 4 पे चले जाओ. 4 से पूछो 4 के back में क्या है? 4 के back में 5B है. So 5B goes to the right. What is in front side of 4? There's nothing in the front side of 4. So there's nothing in front side of 4. Simple. The last one we have visible surface ray tracing. So we try to trace the light which begins at the camera or viewer's eye and it is moving through an image plane at a particular given pixel. So from the pixel's positions, the rays are projected out to the scene to determine which object is visible at the point. So this backward tracing approach is called as eye tracing, which is done by firing rays from the camera rather than forward tracing from light source. So forward tracing may we go from light source. But here we start from camera and go to the image. Okay. So what we assume is, we assume an equation which is surface minus ray is equal to 0, and the ray equation is given by RT is equal to T into P minus C. So P is a position of origin of the ray, that is either a camera or an eye. C is a point along the ray, so that is your direction of view. जिस direction में आप देख रहे हो वो. T is a parameter that typically determines the position along the ray. Now in this case, you have three cases. Case 1 says that there are no real roots. So when there are no real roots, the surface and the ray do not intersect. Case 2 is that you have one real root. So the ray is tangentially going to graze the surface. And the third case is that there are two real roots. So from both intersections, we will use the one which has the smallest value. So जब case 3 होता है, हमें वो object दिख जाता है. So whatever complex surfaces are there, this particular one works really well and it can be done in parallel. The issue is it is computationally expensive. So the next thing that is given in this chapter is the comparison of all the units. So the approach, the formula or the algorithm, what type it is, whether it is object space or image space, and what are the advantages, disadvantages. You are supposed to do this table as well. Thank you very much.